Probably I shouldn't have stopped this thing.
Recording in progress.
Okay, so hello, can you hear me?
Yes, sir.
Yes, sir.
Okay. So seismicity refers to the frequency, distribution, and magnitude of earthquakes in a given area over a period of time. So this explains seismicity. And it's as a result of, it's caused by tectonic activity. What is tectonic activity? Movement of the earth subsurface, or movement of the ground, if I can use that word. It's influenced by tectonic activity, geological structures, and the movements of Earth's lithospheric plates. You know, we all stay on what we are staying called Earth. It's actually a suspended reservoir. No, let me use reservoir. It's a suspended rock body that is floating water. So because it is not continuous throughout, it breaks at the point, it continues at another point demarcated by water. That is why it becomes plates. Now, earthquake zones, also known as seismic zones, are regions classified based on their susceptibility to seismic events. Understanding seismicity is essential for earthquake preparedness, structural engineering, and also disaster mitigation. So you can see earthquake and seismicity are interwoven. So if you want to study seismicity, then you have to know how the layers within the earth moves. And when the layers within the earth moves, what we have is earthquake. So seismicity is primarily caused by tectonic movements. I mentioned this in my definition. Most earthquakes result from the movement of tectonic plates at their boundaries, including subduction zone, transform fault, and rift zones. This thing you get better in geology. Volcanic activities or activity. Some earthquake occur due to magma movement and pressure buildup in volcanic region, then human-induced seismicity. So these are various causes of seismicity or earthquake, if I can just say loosely. So tectonic movement, volcanic activity, and also human-induced activity. What are human-induced activity? Like mining. When you go to quarry and you blast a rock, it shakes the earth. Dam, dam creation. You open a dam, you close a dam, and things like that. When a large volume of water move, geothermal energy extraction can trigger earthquake as well. So this picture here shows, a schematic of a subsurface mountain. Because these are mountains around. This is the sky. These are hills and mountains. This is a flat plain. Buildings. Another layer. Now you can see, if you look at it, you can see that we have 3 layers here. Oh, wow, I'm too fast. Somebody is telling me that I'm too fast. Am I really too fast?
Yes, sir.
Or, okay, somebody is answering. Am I really too fast?
Yes, sir.
No, I don't think so. because I don't want to read. I don't want to read the slide. So I'm just talking straight without reading the slide word for word. So I'll just paraphrase the slides. I move. If you want me to be reading the slide, then that's another thing, which I don't want to do. I will give you the material. So you want to read, you go and read. And somehow I'm recording it. So you can see, go back to go over it again. Because I'm looking at the time, and this slide is more than the other one that I did. So, and I'm looking at the time. Okay. So I'll try to be a bit slow. Oh, I wasted my time. What was I saying, sir? Okay. Okay. I said, okay. Oh, okay. These are layers. I see 3 layers. Now, there's okay. If I ask you now, you're in year 1, you might not probably know. You can see there's a breakage between this plate and this. Okay, let me use this. I hope you can see my cursor. Look at this example now. This one is a bit, this is the same layer, but because of extensional forces, there are tectonic activity caused by extensional forces or compressional forces. This one is caused by extension. When you're trying to expand, so it slides. This one slides against this one. So this is where we call the fourth plane. Because of that extension, it's as if you are expanding something. Because of that extension, around the floor, earthquake, there is eruption here. And the place, the focus of that eruption, that place is called the focus. This is also called the hypocenter, where it begins from. The origin of the focus or hypocenter, while directly up, vertically up at the surface, is called the epicenter. You can see seismic wave generated around that epicenter. You can see the wave, just as you are seeing here. You can see hypocenter, directly opposite is the epicenter. You can see waves that are surface wave. This rally wave is a surface wave. You can see tectonic plates. This is a plate, this is another plate. This is also another kind of surface wave. There are three types of, but majorly 2 types of surface wave. We have the love wave and the Rayleigh wave. While we have two types of body waves. We have the P wave and the S wave. But as we go along, we get to understand that better. So that is actually the reason I included this figure to show you, this wave move within the body of the plates. While this one move on the surface, you can see love waves move like a rattlesnake. You can see why love wave move round like this, as if in elliptical orbit. Look at my cursor. This is how Rayleigh wave move. You can see why love wave move like this, but on a horizontal plane. Snake. But types of waves discuss that. Okay. So you start discussing. So volcanic activity. These are you can see this explains further. That's what happens. Now look at this now. I spoke about extensional forces causes tectonic activity. Now this is called compressional forces. As you can see, this one is joining this. It's as if they are squeezing the two together. So because it's squeezing the two, it's now going under. You can see it here again. This is a layer, under layer, under layer. These 2 layers are within the lithosphere, while this is within the asthenosphere. Okay. So because of that compressional forces causes what we call the subduction. Subduction. This is the subduction. You can see because of that, mountains start developing. You can see this continental crust is now coming under this very one. Okay, so this one is caused because of compressional force, while the one I showed earlier, this one is caused because of extensional force or forces. Now, human-induced activities that can cause, seismicity or earthquake. You can see this is like this area, conventional hydrocarbon recovery, drilling, hydraulic expand it, you blow it, as if you pump water into it to just expand it or to make it fracture, to make it loosen up. This thing causes vibration within the subsurface. And when there's vibration underneath, there's motion at the surface as well. Enhanced geothermal system. You can see these are probably like a, what is it? Like a, there's a name for this. I think I'm trying to remember now. Where you see, I see you are flaring gas, you are flaring air, whatever. You see this in coal factory, even in some mining, in where you get electricity generation and all that, you get these things like this. So wastewater disposal and underground gas or CO2 sequestration or CO2 storage. You see, you pump some gas, some water into the surface. This causes vibration. These are things that we do. These are human activity that can also induce seismicity. Earthquake zones are regions classified based on their likelihood of enhancing earthquakes or experiencing earthquake. Areas that, if I ask you, do you have earthquake zone in Nigeria? I think the answer is no. Okay. So likelihood of experiencing earthquake due to tectonic activity. These zones are determined by factors such as faults, past seismic activity, and also movement of earth plates. That is plate tectonic that I spoke about. Now, in terms of earthquake zones are classified based on seismic hazards level, and tectonic activity. Oh, I hope I'm not too fast again. So these are different types of earthquakes. Okay. I think okay, for the tectonic plates boundary zones. So that means these are areas that experience tectonic plates, activities. Either they are colliding or they are separating. So if they are colliding, it's called the subduction zone. If they are colliding, it is the subduction zone. If they're separating, it's called the divergence zone or divergence boundary. Then if they are moving past each other side by side, it's called the transform zone. So this subduction zone, that is, one is sliding over the other, is found where one plate is forced under another, e.g., is the Pacific Rim of Fire or Ring of Fire. These zones produce the most powerful earthquakes. Then transform occur where two plates slide past each other. The San Andreas Faults in California. See, this place is one of the most active fault zone in the world. It's somewhere in California and the US. These zones experiences frequent but moderate to strong earthquake. Most times it's moderate. The effect of the earthquake is not too strong. So, but sometimes it could be a bit destructive. So the divergence zones that is found and ocean ridge where plates move move apart, generating minor to moderate earthquake as well. So these are from plate movements, sliding past each other, moving under each other, or moving away from each other. Now, there's intraplate seismic zone too. Some earthquake occur. Okay, maybe I'm too fast. Okay. So intraplate seismic zones. Some earthquake occur away from plate boundaries. So now, where we don't have plates now, there's still earthquake. Within plates tectonics, tectonic plates rather. Some earthquake occur away from plate boundaries, but within tectonic plates, of course. This interplate earthquake can still be devastating, such as those in New Madrid seismic zone. So these are areas that we can find this type of earthquake that we're discussing. This is away from boundaries. Also have seismic zone too. Area around active volcanic experiences, active volcanoes experiences earthquake due to magma movements and pressure buildup. Example are in Iceland and Japan. So anywhere we have active volcanic activity are also earthquake zones, because at any time there could be volcanic eruption, and then you know what that means. So we also have what we called the seismic hazard zones. These are places that government and geological organization has classified as regions into seismic hazard zones. They are classified into regions, or let me read that. Government and geological organization classify regions into seismic hazard zones. Okay, which is because of historical data and tectonic activity. Because if a place that has been found to have erupted before, then we might not be too surprised that that place will erupt later in the future. So they could be, those zones can be designated as it can be designated as hazard zone, seismic hazard zone. Because if you don't do that, these zones are used for urban planning and construction regulation. Because if you don't classify those as seismic hazard zone, before you know, you go and build your house or build your company or build your estate on a place that is prone to earthquake or seismic hazard. Okay, now the first one is plate tectonic. So this is what the subduction zone boundary. This is the example you can see. Oceanic crust. This is water body. This is the oceanic crust going under asthenosphere is after the lithosphere. Because of this now, you can see these small blue circles. These are zones of earthquake. These are potential area that earthquake can occur. Okay, so there could be eruption around all this area. Mountain will start building, continental crust will start building, mountain ridge will start building because of that subduction that's happened here. Here is divergence. You can see they are separating. They are separating. This one is transformed. They are sliding against each other. So this subduction and continental collision boundary, they are very similar. You can see this one is easy because it is sliding below this easily. It's just going under. But this one is not sliding. They are just clashing. It's as if two cars had head-on collision. You know what that means?
Yes.
It's just destroyed, having different mountain ridge around this area. So different diagram is also used to explain this picture here or this figure here. You can see compression, just like what we have subduction and collision here. That's what compression can do. You can see this one is sliding under this. This one is going over. So this fault is called the up-thrown fault. This is down-thrown fault. You are still going to learn more about that anyway. So you can see this is another one, down-thrown, up-thrown. One is sliding on under the other one. Why this one? These are the two. This is a transform. Okay. And we have explained this again. Then another, one is this convergence, divergence, and transform. Just the divergence is just they are both separating, transform, and this is this. All right. Okay. So now intraplate, this is the second one of the zones, intraplate zones, which I said, they happen away from plate boundary. Now, you can see this is subduction. The oceanic plate is being subdued over, is going under. Okay.
All right.
So you can see earthquake around this area. This is where we have earthquake. Normally, this is where we have earthquake, but you can also have earthquake generated around this area. Okay. So these are earthquake away from boundaries. Just to show you. For instance, look at the subduction zone 2 here. This is subduction zone here. And look at where you can see deep earthquake around this area as well. This one is showing divergent splits moving from moving away. Okay. So then these are volcanic zone. The third one, subduction zone, causes volcanic eruption at this place. And this another one, the Pacific plate goes under, and this forms this mountain here. This you can see this earthquake occurs here. It also we have deep earthquake here where we have shallow earthquake. So these are volcanic induced earthquake zones. So seismic hazard zones, global seismic hazard map. So if you can locate where Nigeria is, you can know if you have any fear of earthquake. Unfortunately, this, let me see this. Yeah. This is the scale. From where we have this white, these are places that are very free from earthquake. They are not really, earthquake prone. Where which pink, red, and brown are areas with some, earthquake, activity. A lot of earthquake activity. I think this is South America, North America. The San Andreas zone is somewhere here. You can see this is around Asia, Japan, and all that, blah, blah, blah. So this map shows, areas around the globe where we have different earthquakes and how destructive or how serious those earthquakes could be. Now, major global earthquake zones now. So your duty is to probably look at it on the map, all these places now. I spoke about Pacific Ring of Fire, the most seismically active zone. This is the most seismically active zone. Exactly this Pacific Ocean, including countries like Japan, Indonesia, Chile, Western United States. We have the Himalaya seismic belt, a highly active region as well, where the Indian and Eurasian plates collide, affecting countries like India, Nepal, Pakistan. These are places where we hear of earthquake anyway. Mediterranean stroke the Himalayas, which extend from Europe to Asia and all that, regions like Turkey, Iran, Greece, the St. Andreas fault I spoke about, a major fault transform in California, known for high seismicity. The mid-Atlantic region as well. So I think I see pick all these five one after the other. Yes, this is the Pacific Ring of Fire. Where is that place? Look at the Pacific. You can see this is the map of the world map now. You know where this is. This is Africa. This is Europe. This is South America, North America, and you can see where the Pacific Ring of Fire. This is where we call Pacific Ring of Fire. Here you can see the countries that can be directly affected by this. It's just for you to know when you hear Pacific ring of fire, where are the countries that are directly affected by this? Okay, so these are the countries: the Filipinos, the Japans. Adewale Israel, mute yourself. Adewale Israel, mute yourself. Okay. In fact, yes, some parts of North American plates, even America and North America. This is South America. Okay, North America, including part of Canada and all that. This is South America. Now we have Peru, Brazil, and all that. Then it's moved to where we have the Australia and all that. So let's move to the next one. Is the Himalaya. Mhm. It did not touch Africa at all. This is Africa. So look, what countries do you have? These countries are between the Himalayas. Map of Africa around Kano to go from, is it Chad or what is that country? Libya and all that. Where to go to? Those are some of the Himalayas seismic plates. The San Andreas Fault in the US, you can see. It's a transform fault. This is where how it looks like. You can see San Andreas Fault. This is where it is, somewhere here. And this is one map. This is Africa. This is South America, North America. You can see somewhere here. The enlarged map is what I showed here. This is Canada. This is United States. So everywhere here is United States. Now you are going south now. This is Mexico and all that. So the San Andreas Fault is a transform. This is this South Pole. The Atlantic Ridge as well. This is where that is. This is Africa. This is South America. That it could be potential. So if there's earthquake around the mid-Atlantic Ridge, probably some African country will feel it because of the Atlantic Ocean. The wave generated from the Atlantic Ocean will travel to the Niger Delta because that's where it can enter Nigeria. So riverine area in Niger Delta, they should watch it. But I think that plate has been inactive for years now. So zone are aspect of science that helps in risk assessment and disaster preparedness. Understanding seismic zones allows government and engineers to design earthquake resistant structure and implement safety measures to mitigate damage and loss of life. So research is still continuing. Continued research and monitoring of seismic activity contribute to improve prediction and resilience strategy. So that is all I have for you as regards seismicity and earthquake zone. Any question? Intraplate earthquake. Let me see if I can go back to it where I started earthquakes. No, it's before this plate. Okay, intraplate. And I explained that, okay, look at this. Normally, this is where you can see interplate. This is a plate. overpowering this. This is going under it. So there's also earthquake here. So, but somehow, because of the vibration, earthquake could also occur here. Inland coastal earthquake. These are outside the plates where the contact, where we have the contact, where we have a contact between this and this. It can also occur here too. So that is what we call the intraplate. Within the intra, it's not inter now, right? It's outside that plate. Okay. So this is between inter-house sport, between two people. But right now, we are not directly talking about them. It's just something outside those people or outside those two parties. Is that clear? Is as this earthquake. Yeah, between this, yes, the subduction that's happening here that's causing this. So, any other question?
Good afternoon, sir.
Okay. Good afternoon.
Sir, please, has Nigeria experienced any earthquakes before? Or how often do we experience them?
I'm listening.
Nigeria, our country, do we often experience earthquakes?
Extremo, what Nigeria has experienced.
Okay, we have. Okay, sir.
I said it's only extremo. Extremo is just a minor vibration. Okay, the earth did not actually quake. So the movement that occurred was not strong enough to cause destruction that could be termed as earthquake. So it's just a slight movement, a slight vibration that does not cause any significant or major destruction. So Nigeria is not within the earthquake zone. It has not experienced any earthquake in recent history. When I mean recent history, maybe 1,000 years ago. That's what I mean.
Okay, sir. Thank you.
All right. So, any other question? So, class, I will forward the material to me is now on ground, or I still need to talk to the other guy. The geology, I don't know. I'll just look for the first person I see on my contact. Okay. So I will forward the two materials to them. I hope they will forward share it among with you guys. All right. So for the last time, any other question, any other comments?
Recording stopped.